Hello, everyone. Thank you for attending today's webinar, What Next for Mobile Operators in the IoT, presented by GSMA. I'm Monica Alevin, and I'll be moderating this webinar. Our speakers today are John Gohl, Research Director, Telecoms and Networking, CIMA at IDC, Nafisatu Diarra from Orange, Lyle Pakowski, Senior Technology Strategist at Sprint, and Stephen Doyle, Principal Technical Architect at GSMA. You can read their full bios on the right side of your window. A few technical notes before we get started. If you'd like to download the slide deck, please click the Resources List button at the bottom of your screen. The webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please make sure your volume is up. You can find additional answers to some common technical issues located in the Help button at the bottom of your screen. This webinar is being recorded and will be available on demand within 24 hours after the event. We will follow the presentations with a Q&A session. Please submit your questions using the Q&A button on the left side of your screen. All right, let's get started. Steve, please go ahead.
Okay, thank you. So my name is Steve Doyle. I work for the GSMA. I'm part of the IoT program, and as part of our work, we are looking at the subject of beyond connectivity for the IoT. So really, where are the opportunities for operators to extend the kinds of capabilities they offer for the IoT beyond pure connectivity? So some of the areas that we're looking at include edge computing and distributed ledgers. And the seminar today, the webinar today, is looking at the work that we've been doing, supported by IDC and with the support also of Sprint and Orange, in order to work out some of those use cases for distributed ledgers and some of the issues that can be solved with distributed ledgers. So I'm going to halt here, pass over to John, who can run you through the work that IDC have been doing, and then I have a few slides after John's been speaking. If you do have questions, as we were saying, please submit them via the panel, and then we'll review those at the end of the presentations today. So thank you, and please, John, if you can present from IDC.
Okay, thank you very much. It's a pleasure for me to be here with everyone today, and I get to have the opportunity to share some of the findings from this research that we completed recently with the GSMA. Now, the Internet of Things is one of the most popular new lines of business for telecom service providers globally. The operators see that companies and organizations in their regions, in their neighborhoods, are leveraging IoT as a core part of their digital transformation programs. They're increasing efficiency, deploying new services and products, and even changing business models. So companies and organizations in all verticals are increasing their spending on IoT very rapidly, and that creates opportunities, of course, for the telecom sector. So connectivity, it's a critical part of enabling IoT, and telecom providers, they see significant opportunities there. But because connectivity is only one of many technologies involved in delivering IoT, the connectivity spending is only a small share of the total. So as a result, telecom operators are looking for opportunities to do more than deliver connectivity. They're looking at a variety of services that they can offer and roles that they can fulfill to capture more of the value in IoT. So that's why the GSMA and IDC recently worked together on this study, Opportunities in the IoT, Evolving Roles for Mobile Operators. In this study, we wanted to investigate what roles can operators play in IoT and what roles will they play in the future. And furthermore, what is required for them to do so successfully? So to go about this research, we interviewed several operators around the world in all regions, and we asked them for their views. We combined those views with insights also from IDC and GSMA's own analysis. And the results are published now on the GSMA website. You can see the link there below. So during the course of the research, we identified several key roles for operators to play. And these include some services that they can provide, but they also extend conceptually into some other functions that operators can provide to enable and drive IoT forward. The roles that we identified boil down into a few categories. Some of these are about fundamentals, connecting IoT. Some are about building and enabling the ecosystem to deliver IoT, and some are about delivering full solutions to enable customers' digital transformation. First, the fundamentals include connectivity, of course. That's the foundation for every telecom operator's positioning in IoT, and they'll have to excel in that space before they can be relevant anywhere else. But this category also includes IoT service management. That starts with connectivity management platforms that operators must offer to enable customers to effectively use the connectivity. But from there, operators are seeing opportunities to extend their platforms into new areas, such as device management, data management, security, and analytics. So that's a very important category, and it's a very important role in its own right. But moving beyond the fundamentals, many operators are also building horizontal enablement services to enable the ecosystem to deliver solutions. So these include things like cloud and edge infrastructure. These are very important opportunities for operators. Particularly, there's a lot of interest in providing edge computing for newer emergent use cases going forward, and that really plays to operators' strengths. But we also include in this category the role of ecosystem orchestration. And by that we mean that operators are among the best positioned players to incubate the ecosystem, establish partnerships, establish platforms and communities for collaboration, and to help the ecosystem to formulate connections that can reduce complexity for end customers and bring complete IoT solutions to market. So this ecosystem orchestration is a very interesting role that telecom providers can play. It's challenging for them to do that, but they're very well positioned to do so in many markets. There aren't a lot of companies with the local presence, resources, sales force, customer relationships, and so forth to be able to build the ecosystem and to essentially launch the market. Now, in the final column, we have roles in delivering complete solutions. In this category, we have some more advanced service offerings like big data, analytics, and AI. We also have the full vertical specialization. Many operators are aiming to develop vertical specialization in key areas like automotive, healthcare, agriculture, utilities, smart cities as well. So this is very common across many telecom providers globally. But in this category also, there's another interesting one at the top. We've included here the role of prime contractor. Many operators, especially those with IT services, consulting, and integration capabilities, are targeting this role. They can interact with customers at a strategic level, apply consultative sales techniques, and coordinate an army of partners, suppliers, and subcontractors to design and deliver complete solutions. So in this way, the operators are creating quite a lot of additional value in addition to the service components that they provide by providing this role of prime contractor. And this is a very interesting opportunity for many operators. It's unlikely to apply to all operators, but it will appeal especially to those with quite comprehensive IT services and consulting capabilities. So each of these roles that we've highlighted here, they can play an important part of an operator's strategy and allow them to build the market and capture more value. However, some of these roles are easier than others for an operator to perform, and some will provide a more lasting competitive advantage. So that's what I wanted to highlight in the next slide. So here we've plotted these roles across the degree to which they fit with existing capabilities and the degree to which they confer a longer-term competitive advantage. And an interesting point here is that with connectivity, clearly that plays to the strengths, to the current capabilities of an operator, although operators are aggressively expanding their IoT connectivity services. But that really plays to their strengths for obvious reasons. But it does not confer a substantial long-term competitive advantage, unfortunately. So operators really need to look at some of these other services and roles in order to build a bit more of a competitive buffer. The IoT service management, the platforms, those can really play a key part in providing differentiation for operators. And then you see several others across the top of this chart. You can see in particular here the ecosystem orchestration and prime contractor roles are particularly strong differentiators in our view. They're quite challenging to fulfill, and that is, of course, one reason why they provide such an advantage. But they put the telecom operator at the center of the IoT market and the IoT solution. They give the operator quite a lot of visibility into where the opportunities are, and the ability to build the relationships within the market so that they can really establish a strong position in other areas beyond just connectivity. Okay, so within the report, you can see that you can find quite a lot more details on these various roles. We've included several examples of how various operators are fulfilling each of these roles, and you can also find advice on what skills and capabilities are needed and how operators may be able to pull it off. But I'll conclude just with one more slide on recommendations, and with just a moment left in my time, I just want to highlight a couple of things. Firstly, it's important. IoT is really a long-term play, and the skills and capabilities required to succeed in some of these roles are quite extensive. So operators need to build their long-term strategic vision very quickly. They need to plot out a roadmap. But they can't wait to take action. They need to develop their short-term capabilities quickly. Sometimes, for example, in a vertical specialization, that might require an acquisition, but in general, one should not wait to start moving down that roadmap. And then I guess the final point I'll just highlight is that operators can become the glue that binds. The ecosystem orchestration and the prime contractor roles really highlight that point, where the operator can put themselves in the center of the relationships in the market. They'll gain the visibility to succeed, and they'll be well positioned to differentiate and to thrive across all of the roles that we're discussing here. So with that, I'll stop and thank you for your time, and I look forward to the following presentations. Thank you.
Thank you, John. And I think very, very interesting. We'll hopefully have some questions at the end to address to you. So in terms of the work that GSMA has been doing, we've been working with operators this year to look at distributed ledgers and the IoT, particularly interested in how distributed ledgers can make certain operations much more efficient with the IoT. And we have a report, it's called Opportunities and Use Cases for the IoT and Distributed Ledgers. It's published on the GSMA.com website, and hopefully that you'll take a look at that later. So following on from the themes that John described with IDC, we have looked at those use cases and really focused in on which of those can be considered a core capability that can be used wholesale across the IoT. So that's the IoT foundation area. Which of the distributed ledger use cases will enable more specific services, and again picking up on the vertical sector specializations with whole solutions for particular markets. So the first of these in the IoT foundation stack is in identity. And identity is a broad topic, so we look at identity as a whole. How do you identify devices? What can you do to help with identifying things like firmware versions and software versions that are the right versions to download to your IoT devices? Another big theme in the foundation level is access control, and again, it's a broad topic, so that can be physical access control to a resource, or it could be some virtual access to a system resource. In the service enablers area, the first topic that we pick up there is smart contracts. So really, what can you do, and really innovatively with distributed ledgers and the smart contracts capability that allows really automation of business processes that's fully part of the distributed ledger itself. Of course, we have payments and micropayments in particular, and we consider use cases which are both person to machine and also machine to machine. And the final area on the data sharing is data sharing and integrity. So how can an IoT device share its data with some other system? How can the integrity of that data be proven? And distributed ledgers are an ideal fit for that. In the solutions area, two of those came out particularly strongly. So supply chain, and we know that there's various supply chain solutions already being described with distributed ledgers. Our feeling and something that's borne out by the use cases is the IoT adds an extra dimension to those supply chain cases. So the IoT can provide evidence that goes with something that's being supplied, whether that's location or the condition. And the final area on here is the sharing economy. So seeing growth of all sorts of different solutions in the sharing economy, which are themselves quite self-contained, but using distributed ledgers means that more general solutions can be offered, and with the IoT to again support those use cases. Also, part of the work that we've done with operators is to look at relative importance of these for where the business opportunities lie. And we've got a rough ranking of all of those, whether the interest is higher, medium, or low. So you can see that there's a broad interest across all of these areas. Different operators have got their priorities in different places, but we're hoping that this work that we're doing now also transforms into some proofs of concepts that we'll be developing over the next year. The final slide, and what I wanted to go through, is within GSMA as a whole, we've been looking at distributed ledgers across many different areas and over some period of time as well. So the first report that we worked on was in our mobile for development group, which is looking at the use of distributed ledgers for things like aid and providing some sort of payment type services that can work with mobile payments. We've worked on strategy papers. We have a publication in mobile identity. The IoT publication that we were talking about here today was published in September of this year, And recently, our GSMA colleagues have published a presentation on the use of distributed ledgers for the IoT as well. So all of these are part of a wider story on how distributed ledgers fit with the mobile industry and where the opportunities are for improving business processes and creating more opportunities. So I will hold at that point. Questions later, but I will now pass over to Lyle from Sprint to talk about the topic of security and distributed ledgers.
Yes, good morning. Thank you very much. Good morning, all. Good afternoon, all. So the science of security is an interesting outcome of the GSMA studies. We think that there's a number of different aspects that are highly important, but of course security probably is at the top of the list. And we're going to spend just a couple of minutes on what that looks like from the issues and problems concerns relative to a secure IoT ecosystem. And so the inventory of things, as we call it, probably more accurately than the Internet of Things. The Internet of Things, in some academics' minds, is a future state that doesn't exist today. Whereas in the notion of the inventory things, it is what we have, is what's connected to a network. And these items have to be identified, and not only identified, secured. And so absolute identity, as you already saw on one of the previous slides, is an important concept of the notion of the science of security. How do we identify the proliferation of appliances that will be looking for access to a network that will not have the fundamental telephone number that is used today to provision an appliance on a network? And so the future state of identity and security become more or less intertwined. We also see that as an extension of security, the notion of hardware-root trust and the distributed ledger technologies or blockchain add to the componentry of layer 7 security. It probably is well understood that layer 7 security today, or application-driven security, isn't totally secure. And so we are bound to find better and more advanced methodologies to attach to layer 7 security that isolate the appliance, keep it secure while maintaining its pristine identity. One notion here, and we won't spend any time on it today, but we wanted to make sure that years to quantum starts becoming a conversation piece within the ecosystem. There obviously are a number of discussion points around whether or not years to quantum or the enablement to hack systems more easily with qubits rather than bits is a subject, but it is also a reality. And using the global and National Ledger Alliances, much like what GSMA is doing here for this framework, is highly important for all of us to engage and have adequate and proper dialogue and plan for it. One of the comments that I think is highly important, particularly in the world of IoT, is feeling secure and being secure should correlate. It is no different than the mobile appliance industry that has become mature. We have to apply those same methodologies to the future of IoT. Some of the observations around the predicates is that how is identity related to protection of an appliance? So in essence, if we can't name the appliance, we can't find the appliance, we probably can't secure the appliance. However, those who are trying to find the appliance to do harm to a network or to a domain certainly have the tools to do so. And so one of the components that we proposed is how do we use distributed ledger technologies or forms of blockchain that would create this notion of true identity. So this enablement would be on networks of truth. So the carriers should, particularly in the case of 5G, start contemplating what does the network of truth really entail? How do we build, or how do we actually architect that system in the future that will give us this notion of of true security with identity. And then, of course, obviously with 5G, this notion of linear data center technologies or microcenters becomes evident, which is actually opens up another attack vector for those who wish to do damage to IoT ecosystems, but it also is a tremendous opportunity to solve some of the problems of the past that we couldn't do easily with core technologies. So is the security of the appliance the most important component, or is it the security of the data, or is it the secure identity, or is it all of these? And I believe that the carriers would come to a conclusion that we have to solve for all of them. One of the things that probably would factor in this is that we have to isolate security and identity based on the silicon components and the carbon-based components. So silicon-based appliances in the future, particularly the higher science appliances like automobiles and the like, will actually become corporations or legal entities on networks, and will have to have some form of identification that withstands the test of time in terms of discoverability and transparency. Lastly, on this particular observation, one of the components that we also feel is that current blockchain or possibly distributed ledger technologies might be a bit too heavily laden with overhead to adequately create efficient and economical systems that would create identity and additional security. And this is something that I believe the carriers must contemplate going forward, is how do we take the technology, the data technology that is becoming more apparent to be a successful result. However, we have to make it more efficient. So securing the inventory of things we have to look at, in terms of an architectural approach, how do we protect the keys that created the secure components and the identity from loss? You simply have to be able to find them. Once you lose your hash of your identity, you lost it forever. Some statistics state that 1/5 of all Bitcoin currency has been lost forever because the owners of their keys have lost their keys. And then we need to protect the keys from theft. That's probably an obvious. But we also have to protect the supply chain. So the supply chain in the future is becoming integrated as part of the entire ecosystem from the beginning to the end. Identity will begin at chip birth and will end at chip termination. So delivering the keys with rules is required, but we also have to trust the instruction set that creates the identity. And so effectively this particular circle, this loop, closes the notion of absolute identity, absolute security, or true security by adding Harvard Root of Trust, whether it's ARM or Intel, onto layer 7 technologies, and then immuting the data that results from these appliances. A good use case here would be like in the case of a future car that has extreme processing power, lots of storage, lots of energy to generate data. It might have the ability with distributed ledger technologies and root of trust to invoice for itself, bill itself, and actually pay for itself on a network as a proxied identity of the owner. And so it's an interesting concept about how we may have to rationalize and normalize these three components into the future state of the inventory of things. And of course, the global community, there's a bit of fragmentation of thought still that exists today. There are obviously, the reason for this call today is to rally the forces together to start thinking about a strategy. Also, with the levels of standardization, is put in place those rules of engagement for all parties of the ecosystem to start solving for these problems. There's a loss of use cases, some of which may be impractical for the use of some of the science that we think, and so therefore we have to continue to do research and find the right space and the right time and the right opportunity to solve for security for IoT. A huge market to protect. And so one last comment in terms of years to quantum. Again, this is a forward-thinking notion. But however, if we don't think about the future, we probably can't solve for some of the problems of the current stage. And so we put this on as a possible future study point that we have to rally around and understand. Some analysts predict that 2022 will be the year in which we see significant effects around quantum in solving, at least in being able to solve for encryption and possibly hack it. And so with that, I'd like to thank the GSMA for inviting Sprint to this call, and look forward to the next presenters.
Okay, thank you, Lyle. Thank you all for attending this webinar. So today we will present two blockchain use cases related to IoT and actually in development or demonstration phase at Orange. And first of all, let's talk about the motivations and interest of Orange in the blockchain IoT field. For Orange, the interest in finding blockchain or distributed ledger technology use cases for IoT is mainly due to two reasons. The first one is that Orange has been positioning itself for some time as a major player in the field of IoT, with a lot of offers for consumers as well as for companies. And on the other hand, the blockchain and DLT's technologies have become more and more important with different possible use cases. And at Orange, we took the blockchain initiative about 2 years ago with several POCs, proof of concept, and anticipation projects in various domains, including IoT or supply chain or healthcare. And so our goal today is to talk about two demonstrators related to IoT and developed at Orange. The first one is what we call a consent management system, and the second one is a generic marketplace, both of them powered by blockchain technology. Now, what is a consent management system? You can think of it as a system where a person wants to give access, like read or write access, to a third party, to something he owns, like personal data, medical data, devices, and so on. And actually, we have applied this consent system both in healthcare. For example, a patient wants to give access to some data to his doctor or his pharmacist, and also in IoT. And we took the example of a person who can give access to his connected door to one of his neighbors. And in case, for example, of emergency, the neighbor can then open the door in its place. Now, these two use cases suppose, of course, that the consent was previously defined and stored on the blockchain. And to give a specific access, the system only has to read or to consult the blockchain in order to see if such a consent was defined, and all this thanks to the power of smart contracts. Now, blockchain, of course, offers many interesting properties in this case, in this consent system, like disintermediation between the actors or traceability of all accesses, and so on. And now, in the next slide, we are going to the generic marketplace using a blockchain platform. Now, for the generic marketplace, the idea is to have a place where some people can publish offers regarding what resources they own, and some other people can make requests following their needs. For example, a resource owner can say, I have a driller available for the next 2 weeks in the case at this address for a rent of X account unit per day. And this will be published as a new offer on the ledger. And on the other side, a requester can say, I need a driller available for the next X weeks in this area for a maximum rent of X account unit per day. And once these offers and requests are published, a smart contract will be in charge of checking the match between the offer, the need, and the access modalities. And if the transaction proposed is accepted by the requester and all the conditions of its execution are fulfilled, now it is then registered in the blockchain. Now, what is interesting is that with this new approach, we are actually developing what we call a peer-to-peer energy system. with the goal to create a virtual power plant based on a generic marketplace to be powered by the excess of renewable energy produced by our households and companies for local consumption. And now, of course, also blockchain gives many opportunities for this use case, like immutability, disintermediation, and verifiability of the ledger. And to finish, let's just talk a little bit about Hyperledger Fabric, which is the blockchain DLT platform we are actually using at Orange. Now, as a blockchain platform, Fabric has some interesting features like modular design with pluggable consensus or some interesting performance characteristics. Now, there are two main reasons why Orange choose Fabric. The first being the permissioned aspect. That can be very useful when you want, for example, to set up some business-to-business use cases. And the second reason is that Orange already had some internal skills on Hyperledger Fabric. So it was just easier for us to move directly to Fabric. And finally, I would say that there are actually some studies being conducted in Orange to see if there would be some alternatives to Fabric that can correspond to our blockchain IoT use cases. For example, it can be Ethereum, permissioned version of Ethereum, or some other, something like a IOTA platform or so on. And that's all for me. Thank you for your attention, and all your questions are welcome. Thank you.
Okay, thank you. Thank you all the presenters. And we're now moving into the Q&A session. We have some questions that are being raised already. I'd first like to start with a question which was related to Lyle's presentation, and it was to please explain in more detail what's meant by carbon-based identity. So Lyle, would you be able to answer that, please?
Oh, certainly. Thank you for the question. It's one I get quite often when I distinguish silicon-based identity to that of carbon-based identity. Of course, it's kind of a glib comment in which all of us humans are carbon-based, so it's actually the human identity, it's us. And our identity obviously is at risk today too, because we take on multiple forms of identity. It's our name. In the case of a network, it might be our subscriber number or a telephone number. In the case of a government, it might be your social security number or some government ID. And so this plethora, or these numbers of different forms of identity don't integrate, don't translate, they don't certainly allow for easy access to data, particularly in the world now as GDPR starts to move and become pervasive globally. Carbon-based identity is going to become an issue in which we ratify back to a proxied identity, an identity that can't be used and can be discovered, but not easily hacked. And the same principles will apply to that of silicon, of processors, of carbon, steel, and aluminum and plastic, because these capabilities, like human owners, will become legal entities, and they have to have a discoverable, usable, but yet difficult to hack identity. So what we're doing here with this notion is actually equivalating that human nature of ID, a name or a number, to that of a high science thinking appliance on some network domain.
Okay, thank you, Lyle. The next question I'll ask to John, and it is, what about certification of IoT devices and onboarding capabilities and services? And I think we're particularly interested in the distributed ledgers angle on this, John. So yeah, please tell us what you think about this.
Oh, okay. Well, I mean, sort of before getting to the distributed ledger side, I mean, the certification of devices is a critical role. It is something that we could have broken out separately in our report. It's a role that many operators are playing, and they see it as important for them in order to enable the ecosystem. In reality, we've essentially bundled that into the broader category of ecosystem orchestration. It's part of the many activities that are needed to enable the ecosystem, to enable new vendors to launch, and to enable vendors to bring new devices to market in an affordable way. There's been a shortage of clever new devices in some use cases, and a lot of vendors are putting in great effort, including many startups and large established vendors, putting in great effort to bring clever new devices to market. And operators are dependent on that in order for them to sell the connectivity and to get the solutions to market. So making the sort of device certification, streamlining that, making it more affordable, more efficient, and easier for vendors is kind of a key role, a key part of the ecosystem orchestration. I think from the perspective of the security and distributed ledger, I would turn to the other speakers as they'd be able to speak to that more.
Thank you, John. And yes, I'd be interested, turning first to Lyle, if he could pick up on this topic and talk about the security angle that you were talking about there.
Is there, in terms of certification, is that the nature of the question?
Yeah, principally that's right, Lyle.
Yeah, so okay, actually it's a good question. I believe that there are some activities underway to kind of define the different tiers of IoT appliances, or those appliances that are inventory components on a network or a domain, with the lowest tier being things like sensors and the ubiquitous toaster, and the thing that you hear about quite commonly about we have to secure it on the network. The second tier would be obviously things that have a higher degree of intelligence, probably a more pervasive connection to a network, like a refrigerator perhaps, something that is able to order the milk for you on your behalf, if that is exactly what you want your refrigerator to do. And then lastly, the higher science, what I call higher science appliance, a high machine like a car, truck, tractor, or even a building, an appliance that has processing power, has the ability to store data, create data, analyze data, dispense data. And these different levels, these three different tiers that I'm speaking of, have different degrees of security related to their certification. And so I think that this notion of certification of will an appliance actually function on a network, should it function on a network, to what standards should it be applied to it on the network, and then how do we secure it? Security is a very difficult thing, because if you take a look at the large organizations, and just the most recent one we're reading about, these organizations and these appliances in the future will be considered to be secure until they are deemed not. And so it's an instantaneous going from I'm secure to not being secure. And we have to start thinking through all of the elements that create an identity that is secure on a network. And from that point, then yourself as a human, or yourself as a silicon entity, can become more secure. Okay,
thank you, Lyle. Next, I have a question which I think I'll turn to Nafsatu from Orange, and well, it's a two-part question. So the first part is, which capabilities are needed to apply the hyperledger concept to the IoT? And the second part of the question is, how far can we go down the IoT layers applying this technology? So Nafsatu, please go ahead.
Okay, thank you for this question. The first part of the question is which capabilities of Hyperledger Fabric we need for IoT use cases. I think there are some interesting characteristics like performance or scalability. The need to take in account a certain amount of devices and so on. And these are the main reasons to choose Hyperledger Fabric for IoT use cases. And also the modular approach with some consensus. I talk about a pluggable consensus, and this is something really interesting when you have, for example, use cases, an IoT use cases that involve some partners who can decide between them how to reach the consensus and something like that. And for such use cases, I think that Hyperledger Fabric is very interesting. And can you repeat the second part of the question, please?
Yes, of course. How far can we go down the IoT layers applying distributed ledger technologies? Okay.
Actually, I don't have the correct answer to this question because it is something I did not investigate in my study, but I think maybe the other presenter can have a good answer for this.
Sure. Lyle, I wondered, would you be able to comment on any of the things that Sprint's working on with regard to just how far distributed ledger can move down the layers of the IoT?
Certainly. Thank you. So, as probably with most carriers, there are a few budgeted projects underway. Obviously, we are working on a global wireless enablement to do cross-carrier payments, but that's a transactional form of blockchain. To your point, from a specific point on IoT, what we're interested in the world of Internet of Things is change in state, not necessarily the transaction that is a fintech transaction or the exchange of money, but what does an appliance do on a network that creates value? So if it's on or off, hot or cold, fast or slow, these changes in state become really critical for us to track. And so we think that microcontracts, or the ability to programmatically inject these rules of engagement into the chain code, to allow for appliances to become semi-autonomous on a network, such that they can act on their own behalf. And so our initial guidance internally to Sprint is to understand that concept. In the future, if appliances are on a domain and they're mostly autonomous, how do we give them command and control without losing control and without abrogating security? So change in state happens to be one of the things that is interesting to us relative to DLT. And the second component to that is that we're interested in not overloading the network with consensus algorithms. It'll make no sense for a carrier to deploy systems that on the one hand make data gathering and analysis more efficient, but then add a significant back end with trying to create systems that place the block. And so minimum viable consensus should be a strategy we're considering. How do we hybridize the notion of placing blocks such that the information is known to be true? And then secondly, how do we trust the instruction set that created the blockchain to begin with? And those elements are, but right now we're investigating internally to see what science that exists today in the market can be brought back into a carrier and applied in a provocative and possibly even profit-making fashion.
Thank you, Lyle. And referring back to the work that GSMA has been doing, we've already seen that there's interest in the use cases around things like access control and identity, and those would be quite low level in terms of capabilities for the IoT. We're also aware of initiatives which are looking at putting blockchain or distributed ledger capabilities really close to the device. and seeing initiatives like IOTA, which will allow for that broad scalability. So even something as simple as data sharing is enabled via a device directly working with a distributed ledger. So yeah, definitely there's lots of scope throughout the IoT service layers or the application layers in order to make this work. The next question, and I'd like to turn to John at IDC. Again, it's a two-part question. I'll ask both parts first, and then we'll look at this. So, is it plausible for telecom operators to fulfill all these roles? And second part of the question, can they really compete against global technology vendors, for example? So, John, if you'd like to take that.
Right, thank you. So those are certainly very linked. If they're able to compete, then they against those technology vendors, they should be able to fulfill more of the roles. And can they fulfill all of them? It's likely that most operators will not be able to fulfill all of the roles. A small number of operators with quite extensive and diverse fundamental capabilities across ICT and into new technology areas, they may be able to do so. As we saw with the prime contractor role, that particularly will depend on having the IT services, consulting, integration, and related capabilities. So no, most operators will not be able to address all of the roles effectively, and they'll have to choose carefully what their positioning should be, what's most effective for them, and that relates then to the other half of the question, because as they move into these other roles, especially as they move further from connectivity and the connectivity management platform, they are facing quite extensive competition from other kinds of players. So they will need to take an ecosystem approach. They will need to think about forming quite a few partnerships, forming an ecosystem around them with many diverse partnerships, and developing a value chain for each solution they want to sell, sort of mixing and matching the different pieces, the different partnerships to go to market with the best offer. So it will be tricky. They will need to choose carefully what is right for them and not try to fulfill all roles at once. And they will need to recognize that they face tough new competition, so they need to choose carefully where they compete and where they partner.
Thank you, John. And we'll just move on to a final question here, and it's really following on from that around partnerships, but to Nafisatu at Orange. The question, who are the main partners of Orange when deploying a blockchain DLT use case? So please can you answer that?
Sorry, can you repeat, please?
Yeah, sorry. Who are the main partners of Orange when deploying a blockchain DLT use case?
Okay. Thank you for the question. So the main point we consider is the first point we consider is just to see the requirements of the use case. So the first part is to consider the requirement of the use case, to see whether or not blockchain or distributed ledger technology may fulfill all these requirements. And once this is done, the next step we consider is to decide which blockchain or DLT platform to choose, because there are a lot of platforms like Hyperledger, like IOTA, like permissioned Ethereum, like Quorum, and so on. And this is a big question to decide which blockchain platform is more suitable for a given use case, and in particular for given IoT blockchain use cases. So I would say these are the 2 points.
Okay, thank you. So we are getting close to the end of our time today. I think at this point we'll close the questions and I'll pass back to Monica to wrap up the session. So thank you.
Yes. Okay. Yeah. Thank you. I just want to thank everybody for attending this webinar today and submitting so many great questions. I'd like to thank our speakers for participating and GSMA for presenting today's webinar. This webinar has been recorded. You will be able to access the recording within 24 hours using the same audience link that was sent to you earlier. Thank you again for joining, and we look forward to seeing you again at future events.